Why it's difficult to do operations in a public cloud, especially when you start going multi-cloud. First of all, if things break, you don't really have any proof that this is the cloud provider's fault. Usually they will try and blame you. You can only do so much on your end. You don't know what's going on the other end, so you can just patiently wait. If you really think it's their issue, you just have to wait, nag them a little bit to fix it. Then you don't have those traditional tool set that we know from on-prem, like ping, traceroute, packet capture. It's not available in all of the clouds. Some of those clouds make it slightly better, the other worse, but there's no unified way of doing that. Again, black box, all of those clouds don't expose all of the underlying networking, all of the underlying configuration to you. So you can only guess what's happening behind the scenes. When you try to automate things, infrastructure as a code, great, but then sometimes it may be difficult to debug because maybe you are the only person in the company that know actually how this script works and what it actually does and how to debug it. Sometimes your people who are really advanced in the networking suddenly have to start doing like the basic support cases because they are the only ones who would know how things are being configured. All the world is pretty flat. There's no hierarchy like we had back in the on-prem. There's no clear physical separation of different elements. And when you're starting, the more you scale out, the more challenging it becomes to operate and monitor everything. Going back into our controller, we have great troubleshooting tools. And one of my favorites is Flightpath. When you're logging into our UI, you go into troubleshoot Flightpath. What this tool does, it analyzes the configuration of the cloud networking to tell you whether a couple of endpoints, couple of instances, couple of VMs should be able to communicate or not. So how does it work? You select your source. It can be an instance or an IP. You select the cloud where this virtual machine is running. Let's say it's an instance in AWS, in Frankfurt, in my spoke 1. This is my test VM1. And then I select an instance as the destination. Again, Frankfurt, another spoke, an instance here. I want to check if ICMP on those would work. I scroll up. So I ran this test before, so I'm just showing you the results. It will take a few seconds just to pull them. So what we analyze here from the very start, on the source side, we see security groups. Okay, good, nothing is blocking this traffic. Then we have route table, good, it's forwarded correctly. Network ACL, great. Our spoke gateway routing table, great, all green, and the transit gateway routing table, green. Now on the destination side, security group fail. Okay, weird. ICMP rule probably somebody did a typo. See, take a look here. It's 000/32. Somebody must have mistyped something. So only so this ICMP rule is offending. It's not allowing ICMP traffic. But let's take at anything else. Route tables, good. Network ACLs, good. Spoke gateway route tables, good. And transit gateway, all good. So now actually our controller gives you the link directly to AWS's console. Let me quickly log in. We have been taken to the page where this security group is already selected. So I see my offending rule. Okay, I can edit it. Okay, I want to allow traffic from anywhere. So I don't have this ping running anywhere in the background, but this is it. We have solved an issue. And just want to highlight something. You can use source instance and maybe a destination IP. So you can test connectivity, maybe to the public internet, maybe to some resources that we don't manage. Maybe this is your on-prem that you would be connecting to. So you will just select IP, hit whatever IP you have on-prem, and we would select. We would see, at least from the cloud perspective, how this traffic forwarding will be looking. So really, really powerful. And I will later show you a slide listing what elements you would have to check if you were trying to do this type of activity manually. So we will get back to that in a second. I just want to finish off here in this UI. In another tab, Troubleshoot Diagnostics, we have more tools to debug, something that you are very familiar with, something you know from your on-prem world. So this is the, let's say, ping, trace route, trace path. You select the gateway that you want to test the traffic with, very similar to what we did with the Copilot and that graphical representation. You select the interface, you type in the destination, great, and we run those tests. Then we have network connectivity utility. We will just quick analysis of whether all of the rules are providing are allowing the connectivity to a specific destination on a given port. Then super powerful feature, packet capture. You select one of our gateways, select an interface on which you want to monitor the traffic. You can put in some other filtering criteria here, duration of this test, and you hit start. And let's say after 10 seconds, you would get this output. We list all of the packets that we have noticed traversing this gateway, going out on this interface. Really, really powerful. Really, sometimes when you're debugging, you just want to see if the packets are arriving or not. So that's why we have this view directly over here, just summarizing those packets. If you want to download those packets, hit this button, and we generate a PCAP. You download it and you analyze it in your Wireshark. We can try and pinging from the controller level as well. Then we have this network validation tab. This is also a very powerful tool, and we actually go in and deploy a couple of test instances that would check the connectivity. So you just select the cloud, the region where you want it to be deployed, in which VPC, and we go in, deploy those instances, and do the testing. So lots of good troubleshooting tools. Sometimes they're even better than what you've known from the on-prem world. We're just improving and leveraging some other options that the cloud is giving us. You remember when I was talking about the Flightpath testing and how many different elements we are analyzing. So this is a list that you would have to go through if you were to do this type of analysis manually. Everything on the source to destination end, and then the return traffic, basically lots of other elements here. And okay, if you are specializing in one particular cloud and the traffic is going within that particular cloud, you will probably have a good intuition and a fast debug. But now imagine your source is one cloud, your destination is totally different cloud. And then you have to analyze and figure out, okay, what are the constructs here, how they fit into the bigger picture, and so on. So it would get so hectic when multi-cloud environment comes into the picture. And for us, it's just the same thing. You just select source and destination. We don't really care which cloud is the source residing in, where the destination is. Very flexible. We just pull up those native constructs from each cloud and analyze them and tell you what may be wrong and why the traffic may be not going forward. All right. Now we have the troubleshooting tools like pings and so that we already spoke about. Packet capture we already spoke about. So lots of good troubleshooting tools, monitoring tools, as I hope you've seen. Now another topic for operations side, it's automation. We encourage you to do lots of automation. Our controller is fully API ready. Anything that you can do within our UI, you can also do through our REST API. Plus, we have the Terraform. Our Aviatrix is an official Terraform provider. So anything that we configure in any of those clouds, you can export it actually as the Terraform script and then use it in your own automation. And now our controller becomes this intermediate layer between you and all of the clouds that you want to manage. and our controller is basically providing you this abstraction Terraform layer from which you can manage all of those clouds using basically the same code. So this is the API browser. You're welcome to go to API aviatrix.com to check it out. We list all of the calls that you may need. Another thing, I think it has transpired from everything that we've been doing over here. But since we are doing multi-cloud, we are also multi-account. So if you have multiple accounts in AWS, multiple subscriptions in Azure, and so on, you can all pull them in to the same controller and have the single pane of glass to manage all of them wherever your resources are deployed. Plus, obviously, our controller needs some specific level of privileges to manage those accounts. So we make periodic audits to make sure that all of the privileges required by our controller are in check. If something's off, we give you a notification. There's this little star sometimes telling you that maybe some rules allowing our controller access to specific resources or doing specific actions is not available. So we would ask you to go and fix it to continue using the platform. Now, another topic, really important, controller HA. We do it based on the native construct in AWS. This is an auto-scaling group where we basically create an auto-scaling group. This is all scripted for you, so you don't need to worry about it. We just configure this auto-scaling group. If something, and the quantity of our controllers should be 1. If something happens with one controller, we have a notification sent to a Lambda script. We build out a new controller, and we pull the configuration from the backup. An important note, we leverage S3 as the backup for the configuration of our controller. So just keep it in mind that's a good way of doing HA. But also remember, our controller is not really involved in any packet forwarding. It's our gateways that are doing the hard job. Controller is programming them. So even if there's some disruption in proper controller functioning, there's no implication on your data plane. Your transit network, all of your features are working as they were. So you see the process over here. As we were launching the new controller, we moved the Elastic IP from the old one to the new one. So you can keep on using the same IPs for accessing the controller, and we restore the configuration from the S3 bucket. And this is all fully automated for you. You basically enable it with a simple click. Then we have a VPC Tracker feature, really cool and useful. I think we actually have some demo over here. I mean, sometimes when you are managing many of those clouds and many different accounts, you may lose track of all of the CIDRs, all of the subnets that you are using. So we give you an easy way to export a list if you want to keep the list on the side, but also we allow you to search through all of the subnets all of the CIDRs that we see in your accounts where any of the resources like virtual machines are deployed, and then you can quickly test if this CIDR is already used or not. It's good to keep track of it. I mean, you will sooner or later you will probably run into some overlapping CIDR scenarios, but if you can avoid it, I think it's just better to avoid it. So thanks to the way we work and the visibility that we have in all of the clouds and all of the accounts and subscriptions that we manage, we can quickly scan all of them and tell you if somebody's already using that subnet. Then another really nice feature, it goes into the network correctness validation that we stand for. For instance, when we are orchestrating the TGW in AWS, you remember this is their native transit functionality that we can plug into and orchestrate. We keep the state of the expected state of all the routing tables in the TGW. And we can compare it with the real state. And if we see that somebody may have gone in and done some manual modifications, we will just flag it to you. The same actually goes into all of the VPCs that are attached to TGW. So we would analyze not only the routing tables of the TGW itself, but also all of the VPCs that are attached to that TGW. So as you can see, network correctness all the way. Then we have metrics for our traffic passing through the gateways, many different ways in which you can look at it. There's a list of stats that you can select. You select time range, you can select gateways that you want to look at specifically. So it's really easy to monitor who is generating or receiving lots of data. We have, when we're doing TGW, we are giving you the full list. You may have many TGWs spread across multiple regions, many VPCs connecting to all of them. We give you a list, all of it in one place. You can easily filter, you can easily check which VPC is connected to which TGW, and so on. Okay, I think, yeah, this demo shows that we can actually go into from this console, we can go into the details of the VPC route table and TGW route table. And if there's our transit gateway associated with it as well, we would also show it to you. And then we have the VPC diagnostic option. You can select a VPC or a VNet, and we will just pull up all of the information for that specific network and generate this nice text file covering all of the details. So you can easily download and have all of the details. Maybe this can be useful for you to take a snapshot of the current status. If something changes in the network in the future, you can generate it as well and compare what were the changes in all of those outputs. So this is a nice way of capturing all of that data in one place. And then Chargeback. Maybe Chargeback is not the best description over here. Maybe it should be like Showback. What basically we're trying to see over here is that in our controller, you normally see the summary of all of the resources that you have deployed. And in the default view, in our main dashboard, you have aggregated data for all of the accounts, all of the clouds, basically for all of the cloud network that we are managing. But then in this view, you can select specific account or maybe specific subscription that you want to take a look at and figure out how many resources they are actually using. So that gives you the extra visibility into what each account, what each project is using. But also, if you need to correlate that information with some billing charges, it's easy here just to figure out who was using most of the resources in the network. And other cool topics on the operational side, something I want to highlight. It may come up on the test, I don't know, wink, wink. So the upgrades of our setups are really hitless. So the way it works, whenever there's a new release coming up, you will get a notification over email. And as you may remember from my controller, there's this little new button, a new version is available, hit upgrade. And then we will actually take you to this particular view. You can do a dry run, which means that we will connect and check the connectivity to all of the gateways that we have deployed to make sure that the controller can access them and deploy new packages if needed on those gateways. And then when you hit upgrade, this is fully hitless, so don't worry about any traffic going down. This will not happen. What happens is controller starts running its new software package, and then we go into all of the gateways and deploy new software packages on them. But it does not involve any rebooting, restarting of the instances. So you shouldn't be noticing any drops in your network. I've been doing it many times, just live traffic, and I was not seeing any drops. I was connected to some of my VPN gateways, for instance, and my connection stayed exactly the same. So no worries on that. Whenever there are security patches, we announce them, and then you have obviously also ways to deploy them. And finally, high availability. We've discussed it for the controller itself. So you remember this is this backup to S3 and pulling the configuration back to it if the controller needs to be reconfigured. But then for gateways, we always recommend building them in active mesh mode, meaning that we deploy a couple of gateways in every VPC that we want to manage. So there will be always 2 transit gateways in each spoke network, like VPC VNet. There will be 2 spoke gateways. There will be like a crisscross type of connectivity. So there will be actually 4 tunnels between those 2 pairs on each side. If any of those nodes failed, there's still the other one functioning just fine. So basically you can lose half of those nodes, 1 on each side, and we will still keep on operating just fine. Sometimes you may just not notice some throughput implications, but if you've lost 2 gateways, you probably have some other things to figure out.